Jain friends, myself Sachin Jain, Assistant Professor, Ajay Kumar Garg Engineering College. So, in the series of lectures of web technology, and today is the third lecture, and we will discuss the complex topic abstract classes and interfaces. So, these are the outlines of the lecture: abstract methods, abstract class, interfaces, instance of keyword, and adapter classes. So, these are the things that we will discuss in today's lecture. So, what is abstract method? You can declare an object without defining it. Like I want to define an object that belongs to a class person, so we can declare it. In a similar way, a method can be defined without declared without defining its body. So I can write a method. I can define a class that is a public class. I'm defining a method that's name is draw, and this is a kind of public, and it is in abstract in nature. You can see that there is a semicolon here, not there is a body of this method. So when we define a method that doesn't contain its body and it's only have its declaration part, then that type of method is called as a abstract method. So you can see that there is no body of this method draw. So when we define a method without its body and we use abstract keyword before the name of the method, then that type of method is called as an abstract method. A method that is declared but don't define, it's called as a abstract method, as I told you. Now there is a abstract classes as well. So what is abstract class? Any class that contain an abstract method can be considered as an abstract class. So a class that contain abstract method is called as an abstract class. So you must declare a class with the keyword name abstract. So just before the name of the class, you will use abstract keyword as we have used with the name of a method. So this is the syntax of an abstract class declaration. So you will use abstract keyword before the name of the class. Here my class is the name of the class, and I'm using a keyword abstract just before the name of the class, and then we will use the declaration part. So an abstract class is also called as an incomplete class because the method defined inside this class are kind of abstract, and the method bodies are missing here, and you can't directly instantiate these kind of classes. So you can't create the object of an abstract class. So but an abstract class can be extended in a subclass. You can extend a class or kind of abstract class inside this subclass. If a subclass define all the inherited abstract method, it is called as a complete class, because all the methods that are declared inside the abstract class will be defined inside the subclass that will inherit that abstract class. So that subclass will be complete class. If a subclass doesn't define all the inherited abstract method, then this class may be considered as a abstract class as well. You can declare a class to be abstract even if doesn't contain any abstract method. So a class can be considered as a abstract class if it doesn't contain an abstract method. So a abstract class can have abstract method as well. Abstract class can't have an abstract method. The objective of making a class as an abstract class is that we can't create its object directly. So why we have an abstract class? Suppose we want to create a class shape, and there are subclasses named oval, rectangle, triangle, hexagon, etc. And you don't want to allow creation of a shape. So the one only particular shape makes sense because shape can be identified with the name of either rectangle, triangle, hexagon, oval, etc. So if shape is an abstract, you can't create a new shape. So what you can do, you can create new oval, new rectangle, new hexagon, new triangle, etc. So abstract class are good for defining a general category of a class that is containing some concrete information. So let's see an example of an abstract class. So I am defining a class name is animal, and because it is a kind of abstract, so I'm writing a abstract keyword just before the name of this class. And this class contains two methods. One is eat and another one is breathe. And both the methods are the kind of abstract method. So here there is no body of these two methods, right? So this is a perfect example of an abstract class, and the class that will inherit this class animal can define the methods of this class. Eat and breath method will be further defined inside the class that will inherit this abstract class. So directly we can't create the object of this animal class, so this class can't be instantiated, and any non-abstract class of animal must provide the eat and breath methods inside that class. So the class that will inherit this animal class will define eat and breath method inside that class. So what is data abstraction? Sometimes we want to define a superclass that declares the structure of a given abstraction without providing a complete implementation of every method. So data abstraction can be achieved with the help of by making of class as an abstract class. So a class that determines the nature of the method that the subclass must implement, and to declare a class as an abstract, we just need an abstract keyword in front of the class name, as we have seen in our previous example. And there can't be we can't create the object of abstract class, and any class that contains one or more abstract method can be declared as a abstract class. So let's see an example. There is a class A. There is a class A, and this class contains two methods. One is call me and another one is call me too. Here call me is a kind of abstract method and call me too is a non-abstract method. So you can see that there is no declaration part of for call me, and there is a declaration part for call me too, because this method is not abstract. So an abstract class can have a method that can be abstract or method that can't be abstract. So because this is kind of abstract class, so the class that will implement this, that will extend this class will define the method called call me. So there is a class, another class B, that is extending a class A. So call me method is defined here. Now we can create the object of B. So we can't create the object of A because A can't be instantiated. We will create the object of B, and then we will, with the help of object of B, we will call the method call me and call me too. So in this example, we can see data abstraction can be achieved with the help of a class that is a kind of abstract class. Now another topic of today's lecture is interfaces. So what is interfaces? An interface that declares a method but doesn't supply bodies for them. So a interface is a kind of similar to a class that doesn't have method bodies. As we can see that in abstract method, method doesn't have body, and in a similar way interfaces have a methods, and that method doesn't have a body. So to define an interface, we need a keyword called interface just before the name of the interface. So to define a class as an abstract, we need an abstract keyword. To define an interface, we need a keyword interface. So here we will write interface as a keyword and the name of the interface. And all the methods that are written inside the interface are kind of abstract method. There is no name, no keyword before the name of abstract, before the name of the method. There is no keyword abstract, but the pattern is very similar like a abstract method because there is no body associated with the methods. So we are just declaring here. We are not defining the body of the methods. So all the methods are implicitly public and are kind of abstract method. You can't instantiate an interface directly. So interface can be implemented with the help of any class. So interface is like a abstract class. None of its methods are defined, we can see, and an interface may contain constants or a final variable. So interface can have a final variable or constant, but its method doesn't have their bodies. So how we will implement an interface? So you can extend a class, but you can implement an interface. So to implement an interface, we need a class that will implement all the methods of an interface. A class can only extend by another class, but in case of interface, it can be implemented and it can implement many other interfaces as well. Now let's see an example. I'm defining a class my listener, and this listener class, my listener class, is implementing various interfaces. So if we want to make a things like multiple inheritance where we have two or more basis class, that similar concept can be implemented with the help of interfaces. And to implement an interface, we can have a class that can implements various interfaces. So you can say a class that implements an interface, and you are promising to define all the methods that were declared in the interfaces. So when you will implement the interface in a class, you need to define all the methods that are written or are declared inside the interfaces. So for example, there was a interface named with key listener. So if my key listener is a class that are implementing this key listener, so all the methods that are written inside the key listener interfaces will be defined inside this class. So there is a body of these methods inside this class. So always keep in mind that when we are declaring various methods inside the interfaces, we need to define inside the class. Partially implementation of an interface. It is possible for a class to define some but not all the method inside and defined inside in an interface. So it is possible. For example, I'm making a class that is kind of abstract class that is implementing the key listener. So key type is a method that is defined inside the key listener interfaces, can be defined inside this class. Since this class doesn't supply any other methods, it has to be promised and it must be an abstract class. So this class is a abstract class. And you must label it such with the keyword abstract. So you need to write abstract keyword here. And you can even extend an interface, or you can add a method inside the interface as well. So, so you can see that the interface funky key listener is extending another interface key listener. So interface and interface can extend. A class will implement an interface and class will extend a class. So why we have an interface? So the class can only extend another class, but in case of interfaces, it can implement multiple interfaces. So multiple class can't be extended inside Java. So if we want to extend multiple class, then we can opt the properties of an interface. So we can implement multiple interfaces. So this is the main reason of using the interfaces. And multiple inheritance concept that is not supported by Java can be fulfilled with the help of interfaces. In writing of applet, it is common to have one class that implement various or different listener. So this thing is possible with the help of interfaces. For example, you can see that there is a class myApplet that is extending a class applet, and that is implementing various interfaces. So when we want to implement various interfaces, we need to use the concept of the interfaces. Second reason of using the interfaces is that you can write methods that work for more than one kind of classes. So in this situation as well, we use interfaces. Now, what is instance of keyword? Instance of a keyword will tell you whether a variable is a member of a class or interface. So if you want to know that whether a variable is a member of a class or an interface, then you can use instance of a keyword. For example, I'm writing a class dog that extends animal class and that implement. Now, if I want to know that Fido is an instance of a dog, Fido is an instance of animal, and Fido is an instance of pet, then you can see that Fido is an instance of dog as well, Fido is an instance of animal as well, Fido is an instance of pet as well. So the answer will be true. So the instance of keyword will help you to know whether the variable belongs to a class or interface or not. So let's see again an interface. When you want to implement an interface, you promise to define all its functions are declared inside the interfaces. So if you only care about a couple of these methods, then what you will do? You need to make a class that is called as adapter class. When we have an interface where there are various methods, but somehow you want to use couple of these methods, then you can make a class that is called as a adapter class. So what is adapter class? An adapter class is a class that implements an interface and provides empty method bodies. So for example, if I'm making a class key adapter that is implementing the key listener, then we can make methods that is empty. So adapter class is a class that have the methods that doesn't have their bodies, and you can override only these methods that you care about. So those methods that you want to use, you can use only those methods. This is not elegant, but it works, and Java provides a number of adapter classes inside that. So what is the summary of today's lecture? We just discussed the abstract method, abstract class, instantiate, interfaces, and adapter class. Abstract method is a method that declare but doesn't have the body. Abstract class is a class that contain the abstract method first, or it can be declared as an abstract. Instantiate, to create an instance of instantiate means you want to create the object of a class or not. So abstract class can't be directly instantiated, and interfaces are the similar to a class but doesn't have the method with their bodies. So the method are inside the interfaces are kind of abstract method. And adapted class is a class that implement an interface but has only empty method bodies. So that's all about the today's lecture. Thank you.